Are we alone? Proxima B, jwst, and humanity's next leap, discovery at 2.0. The age-old question, are we alone in the universe, has haunted human minds since the dawn of consciousness. And now, in the 21st century, with telescopes more powerful than ever before and technology advancing at an unprecedented pace, we may finally be closer than ever to an answer. The James Webb Space Telescope, JWST, one of humanity's most advanced scientific tools, is now peering deep into the cosmos, revealing secrets that were once the domain of science fiction. One of those secrets may involve signs of artificial light, potentially created by intelligent life, on an exoplanet called Proxima B. Proxima B orbits the red dwarf star Proxima Centauri, just over 4.2 light-years away from Earth. It is the closest known exoplanet to our solar system, and perhaps the most studied in the search for habitability outside Earth. What makes it so captivating is not just its location in the habitable zone, but new findings that suggest this planet could be exhibiting unusual light patterns, anomalies that some scientists speculate might point to artificial activity. Could this be the first indirect evidence of alien civilization? The implications of such a discovery are nothing short of revolutionary. If confirmed, it would not just rewrite our understanding of the cosmos, it would reshape the very narrative of humanity's place in the universe. We would no longer be the only known intelligent species. Our sense of isolation would be shattered, replaced by a new identity, members of a broader interstellar community. The impact on philosophy, religion, science, and culture would be immeasurable. But how did we get to this point? The road to this potential discovery has been a long one, paved with technological breakthroughs and bold questions. In 2021, scientists began considering whether artificial lighting or power sources could ever be detected on exoplanets. In particular, they speculated about Proxima B, a tidally locked planet that always shows the same face to its star. The theory was simple yet profound. If a civilization existed there, it might use solar panels on the day side to collect energy and distribute it to the dark side. Such a setup could create detectable light emissions, what scientists called technosignatures. Fast forward to 2024. The James Webb Space Telescope, with its superior sensitivity and infrared detection capabilities, has finally begun to examine Proxima B in greater detail. Early results have shown strange light signatures and heat patterns that do not align perfectly with natural planetary behavior. Could this be the first clue in our cosmic treasure hunt? Of course, caution is essential. These signatures could have other explanations, natural geological or atmospheric phenomena, for instance. But what's important is that we are now capable of asking the question seriously, with tools that can potentially find the answer. This marks a new era in astronomy. For the first time in history, we are not just speculating about alien life. We are actively searching for it, with the real possibility of detection within our lifetimes. One of the main objectives of the JWST is to bridge the vast chasm between what humanity understands today and the vast unknown that surrounds us. Designed to observe the universe in infrared, JWST can see further and with more clarity than any telescope before it. This allows scientists to peer into the early universe, detect faint light from distant galaxies, and even analyze the atmospheres of exoplanets for potential biosignatures or technosignatures. Proxima B is just the beginning. There are thousands of known exoplanets, and many lie within their stars' habitable zones. As of April 2024, over 5,600 exoplanets have been confirmed. Many of these orbit M-type stars like Proxima Centauri, cool, faint stars that dominate our galaxy in number. These stars are harder to study due to their low luminosity, but their long lifespans and stable output make them intriguing candidates for hosting long-lived civilizations. Proxima B, for instance, is roughly 1.07 times the mass of Earth and completes an orbit around its star in just 11.2 Earth days. Despite its proximity to the star, the planet could maintain stable temperatures suitable for life, assuming it has the right kind of atmosphere or energy distribution. The idea that one hemisphere could be cloaked in eternal night while the other basks in permanent daylight adds to the allure. If life exists there, it would be adapted to radically different conditions than anything we know. Our ability to detect signs of such life is growing rapidly. With the jwst, astronomers can now look for atmospheric compositions containing gases like oxygen, methane, or carbon dioxide in combinations that suggest biological processes. They can also search for patterns in reflected or emitted light that hint at unnatural sources, like solar arrays, urban lighting, or thermal emissions inconsistent with natural weather systems. But the search for life doesn't stop with distant exoplanets. Here in our solar system, Mars remains a high-priority target. Upcoming missions will explore the possibility of ancient microbial life preserved in Martian rocks. Meanwhile, the icy moons of Jupiter and Saturn, Europa, Ganymede, and Enceladus, may harbor subsurface oceans warmed by internal heat, potentially providing suitable conditions for life as well. All of these endeavors are part of a larger vision, to understand the nature, origin, and distribution of life across the universe. And as technology evolves, we are not only discovering more, we're also learning faster. Artificial intelligence and machine learning are now integral to the analysis of vast datasets coming from space missions. AI can identify subtle anomalies, distinguish patterns, and flag signals that might be missed by human eyes. This partnership between human curiosity and machine precision is accelerating our exploration efforts. It's also pushing the boundaries of biology itself. Scientists are now asking how life might evolve under alien conditions, extreme temperatures, alternative chemistries, and low or high gravity. Could life exist in liquid methane instead of water? Could it use silicon instead of carbon as a base structure? These ideas are no longer purely speculative. They are forming the basis for new scientific models, missions, and experiments. The quest for extraterrestrial intelligence is not just a scientific challenge. It's a deeply human one. It speaks to our desire to understand where we came from, why we're here, and what our ultimate destiny might be. Every signal we listen for, every faint flicker of light we study, is also a reflection of our own need for connection, our longing to know that we are not alone. The potential discovery of intelligent life would force us to re-evaluate everything, from religious doctrines to political ideologies. It could unite us as a species, prompting unprecedented global cooperation. Or, perhaps, it could highlight our differences and provoke fear. How we react will depend on how prepared we are, not just technologically, but culturally and ethically. In the meantime, the James Webb Space Telescope continues its silent voyage through space, collecting data, unveiling galaxies, and deepening our sense of wonder. Its mission is far from over. As it gathers more information about Proxima B and other exoplanets, the likelihood of discovering signs of life, whether microbial or intelligent, only increases. And when that discovery comes, it may not be as dramatic as a radio message or an alien spacecraft hovering over Earth. It may be a single anomalous data point, a strange curve in a graph, or an unexplained burst of light from a planet many light-years away. But make no mistake, it will be monumental. It will mark the beginning of a new era in human history, one in which we are no longer passive observers of the universe but active participants in a cosmic dialogue. Here at Waves Discovery, we believe that the search for life beyond Earth is about more than science. It's about the spirit of exploration, the hunger for understanding, and the belief that our greatest discoveries still lie ahead. Each mission, each telescope, and each signal from space brings us closer to the ultimate revelation, not just of life beyond Earth, but of our own place in the vast, unfolding story of the cosmos. As we stand at the edge of the unknown, let us remember, the journey itself is as important as the destination. Every new insight is a step forward, a chapter in the evolving saga of humanity's quest to understand the universe. The James Webb Space Telescope has already rewritten what we thought we knew, and it's just getting started. Stay curious. Stay inspired. This is Discovery at 2.0, and our exploration is only beginning.